Okay, so we're going to start out with these 4 examples or 5 examples at the top that we left off yesterday. Okay, so you guys can help me with these. So number 1, what's the square root of 81? 9. That one's 9. Now, on the next one, when you have the negative out in front, you just bring the negative down then. Okay, so it's negative, and then you do the square root of 25. 5. So it's negative 5 then. All right? Let me do this one over. All right, the next one, the negative's on the inside. If that was a square root, there would be no answer. But since it's a cube root, or the index is odd, then you can do it. So what number times itself 3 times would give you negative 216? Say it again, Tom? 6. Negative 6. You got to get the negative. So it's a negative 6. And again, the reason that's true is because negative 6 times negative 6 times negative 6 would give you negative 216. And then on number 4 there, you split it apart. So again, just so you have one of these in your notes, you split it up. You split it apart, so you just make this the square root of 49 over the square root of 4. So what's the square root of 49? Yep. 7, good. And what's the square root of 4? 2. So you just get 7 over 2. And now this last one's the same thing. You split it apart, but this time you're doing the cube root. So what's the cube root of 8? 2. And what's the cube root of 125? 5. And again, those are on those perfect cube lists that I made. So really all of these, right? All of these numbers were on the list of perfect squares and perfect cubes that I gave you yesterday. So that last one is 2/5. All right. But now we're going to go on. This is the new stuff, okay? So we're going to go on to this. Our objective on the board over here is to classify real numbers. So let's start out with, I'm going to do these in kind of a weird order. So we're going to fill this chart in. So the first thing I'm going to do over on the side is I'm going to draw a number line, okay? Yeah, it would probably help if you guys had a calculator too, if you want to grab one. Yeah, you guys should get in the habit of when you walk in the door, grab a calculator on the way in. Again, I'm still charging them, so I still got about 6 more I got to put out. But yeah, get in that habit. When you walk in the door, you guys, when you walk in, grab a calculator. Again, I am recording this, so I need it quiet, please. All right, so the first thing I'm going to do is I'm going to draw a number line for you guys, okay? Over on the side. So I probably have more room in my margin than you guys have. So down here, I'm going to draw a number line. So my number line is going to look like... And those arrows mean that my number line goes on forever in both directions, right? And then let's put like, we'll put 0 right here. 1, 2, 3, 4. -1, -2, -3. That's probably good enough. All right. And we're going to start classifying real numbers, okay? All the numbers that we have in this class that we use in Algebra 1, they're all real numbers. So let's go back to that chart. The first thing I want to do is I want to fill in what... Forget this, I got to get the whole chart on here. What the natural numbers are. So that N on the bottom of that list, that's going to stand for natural. Let me move this just a little bit. So write natural in here. You guys over there, I can make a new seating chart, okay? I will move you. So these are the natural numbers. And the natural numbers, sometimes they're called the counting numbers. Those are just the numbers where you count objects. Like if I was counting students here, I would just go 1, 2, 3. No, I would just count 1, 2, 3, 4, 5, 6 like that, right? So for examples, that's what I'm going to put. So starting with 1, I would count 1 object, then 2, then 3, then 4. And then the dot, dot, dot means the same thing, go on forever, okay? So if I was filling in my number line, all I would have so far for my numbers, go back to my number line real quick here. All I would have would be these numbers, just the number at 1, 2, 3, 4, etc., right? So that's all I have so far. And then if I add 0 to that set of numbers, then that'll give me the whole numbers. So jump back over here. So the whole numbers, that's the W. The whole numbers is that same set we had, we just add 0 to it. So that's just 0, 1, 2, 3, 4, and then so on forever. So that's the set of whole numbers. So then on my number line, that would add 0. So I'd have 0 also. Well, then if I add the negatives of the whole numbers, that'll give me the integers. So the integers, those are actually up here. That's the Z. So those are integers. So that would be, I'm going to put a dot, dot, dot on this end. And then like -3, -2, -1, 0, 1, 2, 3, and then dot, 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 like that. So that's a set of all integers. So then if I went back to my number line and filled those in, I'd pick up the negatives, right? So I pick up -1, -2, -3, -4. So all I have so far on my number line are just those numbers where I made the dots. That's it. But what's missing?
Anything in between, just the whole numbers?
Yeah, anything in between, right? So like all the numbers in between, like 3 and 4. So what kind of numbers would be right here in between 3 and 4? 3.5, yeah. What? And then what else? 3.5, that's 3.5, right? So what are those numbers that are missing in here then? What do you call them? Well, certain kind of decimal. So more generally, like if I did 3 1/4, what is that? That's a what? What kind of number is that? 3 1/4, that would be 13 over 4, right? What do you call that number? 13 over 4. A fraction. Good. Yeah. So we're missing the fractions. So we got a whole bunch of fractions that fit in there, right? For example, you'd have one like right in here. You'd have a fraction in there like 3.5, right? That's the same thing as 7 over 2. So those are the fractions that we're missing that are in between there. So those are called the rational numbers. So those are, they go right here. The symbol for rational is that capital Q. So what you got to remember, I'll put it in the example space here, is that the rational numbers Q, those are fractions. And then I'll write some examples on the side. So let's see, what kind of fractions could we have? Well, we could have fractions like the two that I wrote right here, right? Here, I'll start a list here. So fractions. Remember, fractions means the same thing as rationals. Okay, so what could we have? Well, we could have like a mixed number fraction like this one. We could have 7 over 2. That's an improper fraction where the numerator is bigger than the denominator, but that's still a fraction, right? You could also write that as 3.5, right? So if you have a decimal that just stops, it just ends, that's called a terminating decimal. That's also a fraction. Let's see, what else could you have? You could have something like, I don't know. You could have something like 5 over 6, right? That would be a fraction. This is all one example here. You could have a fraction like, I don't know. Make up another one. 2 3/4. That's the same thing as 11 over 4. That's the same thing as 2.75, right? Notice again, that decimal right there, that just ends, right? That's called a terminating decimal. So that's a fraction. So all of these are the same fraction. So those are all rational. Then you could have one like, how about just something like -7? Is that a fraction? How can you make that into a fraction? Yeah. Yeah. Yeah, just put a 1 under it, right? -7 over 1, that's a fraction. And then what about one like, what if I give you like 0.3 repeating? Is that a fraction?
Yeah.
Yeah, what is it?
1/3.
Yeah, that's 1/3. So if you have like 0.33333 forever, that's actually a fraction. That's 1/3. That's called a repeating decimal. So when you see that bar over it like that, that means that 3 repeats. So if you have a repeating decimal, that's also a fraction. And for you guys that have you guys that grabbed a calculator, let's do another one. If you grabbed a calculator, if you type in like, I don't know, let's make one up here. How about if we do like 0.19 repeating? So that would be like 0.19191919. You're going to have to enter a bunch of those in there. So if you enter in like 0.1919191919, and then if you hit the math button, the math button's in the first column, third row. Then choose number 1 where it says fraction, and then hit enter. That should change that.
1999.
There you go. Yeah, so that changes the decimal back into a fraction. So that's actually 19 over 99. But then again, that's what I want you to see, is that if you have a repeating decimal, so here you got 0.19 repeating, that's actually a fraction. So it is rational. So you got to remember, it's kind of weird. So you got to remember the fractions are the rationals and the symbol is Q. Because like when you do the homework, they're going to give you a number and you're going to have to classify it. So you're going to want to write down either, so far what do we got? So you're going to want to either write down N for natural, Q for rational, W for whole, or Z for integer. All right? So then, so that fills in a bunch of our number line. Because like right there, we put in 3.5 right there, right? But it turns out there's still infinitely many numbers missing between 3 and 4. So like the square root of 9 is what? 3. What's the square root of 16? What's that? 4. That means if you pick a number between 9 and 16, so you guys pick one. Give me a number between 9 and 16. 12. That means 12 is between 9 and 16. So the square root of that would have to be between 3 and 4. So let's do that. So if you do the square root of 12, and you guys try that on your calculator. I don't have one. I'll have to do it on my phone. So we're going to do the square root of 12. So square root of 12. All right, so what I got is I'm going to write a bunch of these decimal places. I got 3.464, 101, 615, and I got a whole bunch of decimal places on my phone. So that keeps going and it never repeats. Hey, what's up? No. All right. So I said don't ask me when I'm teaching or at the start of class. So then that's supposed to be a 6 right there. Now, do you guys see how I did that? We said the square root of 9 was 3. The square root of 16 was 4. So if we take a number between 9 and 16, like 12, and we take the square root, 12 is not a perfect square, right? That is not on that list I gave you yesterday. So that means if you take its square root, you get a decimal that's not terminating, so it never ends, and it doesn't repeat. Those are called the irrational numbers. Okay? And that prefix on there, IR, that means it's not rational, so these are not fractions. You guys see the difference here? So if you get a decimal here, let me see if I can fit both of these on here at the same time. So if you get a decimal that just ends, like this one right here, 2.75, that's a fraction. If you get a decimal that repeats, like this one right here, that's a fraction. But if you get one of these guys right here, you get a number that's, it doesn't terminate, it doesn't stop, it goes on forever, and it doesn't repeat. Those are not fractions. So that's an example of an irrational number. What's a famous irrational number? It has a symbol for it. Pi. Yep. So we'll draw that one in there. So this one, square root of 12, that's a little bit less than 3.5, right? So this square root of 12 right here, that would fit in a little bit less than 3.5. That would go in here, right? And then pi is a famous irrational number. That's like 3.1415927 or something like that. And that keeps going and never repeats. So pi is approximately 3.1415927. So then that number would also fit in there between 3 and 4. That would go in right here also. Does that kind of make sense, guys? So now if you fill in all the fractions between 3 and 4, and you fill in all the irrational numbers between 3 and 4, that'll fill the whole number line in, okay? So if you take those numbers that I have the points on here, the dots, if you take all the irrational numbers and all the fractions and put them in there, that'll fill in the whole number line then. So let's go back and fill this in then. So we got to put in the irrational. So this is irrational numbers. And again, the symbol is I. And for those, again, we just did a whole bunch of examples over there on the side. We're just going to say right here, these are not fractions. All right. And then if you take all of those numbers, if you take the natural numbers, the whole numbers, the integers, the rational and the irrational, if you take all of those numbers, that fills in your whole number line. And that all those numbers together, that makes the real numbers. So the capital R there, those are the real numbers. And so for that, we're just going to write everything below. You guys okay? So if you take the natural, the whole, the integer, the fractions, and the not fractions, and you put them all together, that gives you the set of real numbers. All right, then we got to fill in this little diagram in here. So what was the first one I did? Yep. Natural. So that goes in the small circle here, or the small oval. And then what was the next one? What did I do after natural? The whole. So then the W goes in that second oval. Well, that implies then that every natural number is a whole number. We're making a set diagram here. So if the one circle is inside the other one, so the natural number circle, I can't talk. The natural number circle is inside the whole number circle. So that means every natural number is also a whole number. What was the next one I did? After whole, what did I do? Yeah, integers. That was the Z. So Z would go here. Well, since the whole number oval is inside the integer oval, that means every whole number is also an integer. And then what do we do after integer? Rational, yep. And that symbol for that was Q. So this over here would be Q. That's our fractions. And then, and what do we do after the rationals? That's the irrational, yep. Those are the ones that are not fractions. So they go over here separate. Okay? There's no overlap between the Q and the I. That Q rectangle and that I rectangle representing those sets, they do not overlap at all because the Q are the fractions and the I are the not fractions. And then if you take all of these together, I don't know how you want to do this. If you take this whole diagram all together, that makes up the real numbers. That's R. Okay, so let's try to do this now. So we're going to try to do these examples. Let me see if I wanted to put anything else on my number line there. I think that's pretty good. I should probably label these two that I drew right here. The square root of 12 and pi, those are the irrationals. So I'll put that on your notes. So these are irrational. And again, the note on those is those are not fractions. So that would go for this one and for this one. Okay, let's try to do the examples here. So 4/5. What kind of number is that? That's a fraction, so what do you write? Rational, so you write Q. So all you say for number 6 is it's Q. Now it's also real, but it says at the top of the directions up here, it says other than real, because we know they're all real. Every single number we use in this class is going to be real. So we're not going to write the capital R. Now what about negative 32? Is negative 32, is that in this set right here? No. Yeah, it's integers. And the symbol for integer was what? That's a Z. Now, is it also a fraction? Well, yeah, it is, because we can put it over 1, right? So that's also Q, because it's a fraction. Now, what about the 2 there? Is 2 in this set right here? Yeah, so it's natural. Is 2 in this set right here? Yes, so it's also a whole number. Is 2 in this set right here? Yes, so it's also an integer. And then I could also write it as 2 over 1, so it's a fraction, right? So that means it's also it's a fraction, so it's in here. So what are all the symbols I need then? I need the natural, the whole, the integer, and the rational, right? So that one's N, W, Z, and Q. All right, what about square root of 7? Is 7 a perfect square? No. So what is that one? Square root of 7, that's like the same thing as the square root of 12. Because 12 is not a perfect square. So what do I write? What's that? Is the square root of 7 a fraction?
Yes.
Come on, it's like this one right here. 12 is not a perfect square. What kind of number is this again? It says right above it. Read it off for me. What is it? How do you say it? Irrational. Square root of 12 is irrational because 12 is not a perfect square. So what's the square root of 7 then? What's it called? Come on, say it. It's irrational. So what symbol do I write? I. Thank you. So that is I. What about pi? That's also I, right? I have the example sitting right there. Pi is right here. Pi is also an irrational. Remember, the irrationals are not fractions. Those are decimals that go on forever and they never repeat. So this one's also I. Does that make sense? Now, what if I gave you one? Let's just do one more real quick. What if I gave you the square root of 9? What's that? What's the square root of 9? That's 3 over 1, isn't it? So what is that? Is that a natural number? Is 3 a natural number? Yes. Is 3 a whole number? Yes. Is 3 a integer?
Wait.
No.
Well, look at the list. It's right here. There's the list right there. That's the integers. Is 3 an integer? Yeah, 3 is an integer. It's right here. So that's integer is z, right? And is 3 a fraction? Yeah, because it's 3 over 1, so it's rational, which means you write q. All right? So there was an extra example right there. Actually, I don't like my box I made there. What do you think? You guys okay? I think that was it, right? Yeah, that's it. Okay, so let's do a few practice problems. So let me stop this recording.